Hey, this is Lakin with Team SurgeBotz. In this video, I will give you a quick overview of our 1-pound wedge robot, Corrosion, show you how everything goes together on the bot, as well as give you a quick cost breakdown. And if you want to build this robot for yourself, you can get all the files and motor mounts with the links in the description, but more on that later. The goal behind this robot was to build an Antweight bot for as cheap as possible while still being a competitive robot. Starting with the design, believe it or not, it was all designed in Tinkercad and consists of 9 total 3D printed parts: the frame, bottom plate, top plate, the wedges, and the motor mounts. The idea behind the design was to have a good control bot while still being the same bot upside down, which was heavily inspired by Rotator, because while having a super simple wedge robot can work, it can be very boring to watch. So for this bot, I wanted to make it a bit more interesting. The frame, wedges, and motor mounts were printed with TPU to absorb the shock from big hits. Since TPU is a soft but super strong rubber-like material, the top and bottom plates were printed out of ABS to make the frame more rigid and hold all the electronics in. The top and bottom plate screw into the frame with a total of 16 hex screws, and I ground them down with a grinder so I get even better traction. Each of the wedges is fastened with 2 screws and nuts, with a bigger hole in the wedge acting as a hinge so the wedges will always be riding on the ground. And on the wedges, I epoxied some steel I cut out to protect the TPU and help get under opponents. I also have a lip on there to stop other robots from driving over the top of me. Moving on to the electronics, I wanted to make it as simple and affordable as possible, so it consists of 4 1000 RPM N20 motors, 2 brushed GSCs, 2 batteries, a fingertech switch, and a receiver. The drive motors are held on by the TPU mounts, with 2 screws in each mount. The reason I use TPU mounts instead of ABS is because of the shock absorbing properties of TPU, and I custom designed these to maximize that. It acts as suspension for the robot, which makes it so the N20 gearboxes won't get destroyed as easily. The ESC motor wires split off on each side to connect the 2 motors, so each ESC controls the 2 motors on one side. The battery connector is a splitter that connects 2 batteries and directly feeds them into the ESCs, which have a built-in battery eliminator circuit so I don't overvolt the receiver. And with all of that, let's take a quick look at this robot driving around, and then take a look at the cost breakdown. If you already have a transmitter and receiver, as well as a 3D printer, the total cost will only be about $86. However, if you don't have a transmitter or receiver, the total cost will be closer to $161. If you don't have a printer on top of that, it'll add about $200 to get a printer capable of printing TPU, making the total cost $361. However, if you do already have those things, which most people already do, I'd say $86 is a very affordable price for an Antweight robot. Also, if you don't have a 3D printer, you can also go to any sort of 3D printing service to get those parts printed out yourself. Anyways, that's it for today's video. I hope you all enjoyed watching, and if you ever want to 3D print this robot yourself, the STL files are available on our Gumroad store, and if you want the shock absorbing motor mounts, they're available on our Etsy. Links to those will be in the description. Also, subscribe and like this video if you enjoyed. I hope to do more videos like this in the future.